Hey everyone, thank you for joining us today, and we are excited to host a peace workshop at the Injective hackathon. Today we've invited Dave Kalra from the peace team to host this session, and I'll get him started and go over everything you need to know about how to use the peace Oracle data.
Hey, thanks for the introduction, Vivian. Hi, everyone. I am Dave Kalra. I am a contributor at Pyth, and in this workshop, we are going to talk about what is Pyth, some of its features, how to use it, and then we are going to wrap it up with the demo integration. So let's start with this. The first one, what is Pyth? And Pyth is a price oracle that makes current price for different financial products available on chain which can then be used by different DeFi applications. It sources its price from different publishers that are the market makers, traders, and in the exchange businesses. And these players have the best data and they are providing it to Pit, and which is then available to anyone else to use. We have more than 80 plus publishers, as you can see, and these are like the biggest names in the market. And we have over 120 plus consumers that are currently using us. Just to give you an idea of the price feeds, we publish low latency and high frequency data for more than 200 price feeds, and Injective is like one of them. You can see the data for the last 1 month for this, and you can see all the other price feeds on the Pith website itself. Now, we source our prices directly from these publishers, market makers. This allow us to go beyond just the prices, and we can publish some other data also, some other related data also. One way we use this capability is by reporting a confidence interval. This interval actually represents the degree of uncertainty in the price. For example, here, if the price is $40,000 and the confidence interval is plus minus 50, then it basically tells you that there is a very high probability that the price will lie in this particular range, 40,000 plus minus 50. And if the confidence interval is 1,000, then the price will probably lie between this range, 40,000 plus minus 1,000. Now, any consumer can actually use this confidence interval to protect themselves from market volatility and can be more tolerant to the risk also. They can in fact reject a price if the confidence interval seems to be too great to them. For example, in this case, 1,000. So we have talked about some of the features of Pyth and what is Pyth. Now we want to talk about how it works, and then we are going to talk about the integration, how we can integrate with Pyth. So before this, before we are going to dive into how Pyth works and everything, let's talk about the legacy oracles. And I think most of you here are familiar with the legacy models, with legacy oracles itself. Legacy oracles, they publish price, they push price on chain. This is what they do. This is the base model. And since they are pushing price, they have to pay a lot of fees in terms of gas. And this is a lot of overhead for them. They can't actually, there is a limit to the number of price feeds they can publish. And since they have to pay a lot of gas fees, they can't publish price so frequently. Like it won't be a high frequency price. These are some of the problems with the legacy model for oracles. But Pyth is not doing that. What we are doing instead is an on-demand model. Pyth is not pushing prices to on-chain. Instead, what it does is it allows consumers to query these prices and push them themselves. Since the consumer are pushing these prices, it is very scalable and it is a very scalable and sustainable way to add price updates to on-chain. Since Pyth doesn't have to pay a lot of fees in terms of gas and it is distributed among the consumers, we can we can publish to a large number of price feeds. And another thing is the consumers doesn't have to wait for the oracle. In the case of legacy models, they had to wait for the oracle to publish a price on chain. and then they can use it. The price could not be the recent one, the latest one. In this model, they will fetch the latest price and use it on chain. So it is also a very minimal latency model. So these were some of the downsides of the legacy model that is being sold by the on-demand model, and that is why we chose to go with this. And if you want to read more about the on-demand model, the advantages and everything, there are links to it in the resources section of this presentation, and you can go and read more about them. So let's talk about how Pyth works. Now, before going into what is on-demand model, let's first understand what legacy oracles do. Legacy oracles push price updates on chain, and they do so for every price feed they are supporting their publishing price to. But this comes with an overhead of a lot of fees to be paid in terms of price. And it is not sustainable and not scalable. For every price feed they want to publish to, they will have to pay a lot more fees for that particular price feed. And since that is the case, they can't keep on adding new price feeds, and they can't publish price on chains so frequently. And one of the downside that a consumer can face is they do not have access to the most recent price for this. So these are some of the downside of the legacy Oracle model that most of the Oracle out there uses. But Pyth is different in this particular aspect because we are using an on-demand model. Pyth doesn't publish, it doesn't push any price on chain. Instead, what it allows consumers to pull these prices on chain. The it is now up to the consumer when they want the price, when to push it and everything. Now, in this way, it is very scalable and sustainable because the overhead of all that gas fee is not on Pyth, but it is distributed across the network. And this allows us to support a large number of price feeds. And since a consumer can fetch the price when they need it, they will have the latest price, the most recent one. So this model is also a low latency one too. So this allows the consumer to have access to a high frequency and low latency prices. Now let's talk a bit about the Pyth and the different components, how this all works. I hope the on-demand model and the legacy model is clear for now. So there are many different publishers, and as I mentioned, the market makers, the exchange traders, and everything. So these publishers publish price to Pythnet. Pythnet is an app chain. It is a fork of Solana. So it receives all these prices and it aggregates all of them. And these aggregated prices, what we want to do is basically we want to share this aggregated prices with multiple different chains across the whole blockchain system. In order to do so, there is a need for a mechanism that will allow these other chains to verify the authenticity of these prices. And that is where wormhole comes into the picture. On Pitnet, we are signing and streaming these prices using wormhole. And once we do that, we stream these prices off chain. There is a price service, which is a permissionless service running off chain. And what it does is it basically listens to this latest prices that has been streamed off chain through wormhole, and it stores these messages. Now, what a protocol or any consumer can will do is it will query the current price, the latest price from this price service. Once it has that latest price, it can update the Pyth contract on the target chain, Injective in this case. Once the Pyth contract has been updated with the latest price, anyone on that particular blockchain, that particular network, can use that latest price for their DeFi application. So this is how the whole flow works. So in the last slide, we have talked about the legacy model, the on-demand model, the advantages of on-demand model. If you want to know more about the advantages of an on-demand model, you can follow the resources section in this presentation and you will find a link for that there. Other than that, we discuss how a price service helps the end consumer to get the latest price, which they can then publish it on chain and then can consume it. Now, let's talk about the integration. How we can integrate with it. We will learn that through a demo. So this demo will contain a tab example, an example tab, which we will come to. But before that, let's just talk about the different steps that are involved in integrating with it. These steps, first of all, there is this price service which has the latest prices. The consumers need to query the latest price from this price service. This is the first step. There is an update fee that consumer has to pay, or the one who is updating these prices on chain has to pay to Pyth contract. Pyth contract will store the latest price only if it has been given the update fee. So we need to calculate that update fee, and for that, the consumer or the one who is updating the price will query the update fee for the price update. That is the second step. The third, they will update the Pyth contract with the latest price, and then they can consume it in whatever way possible. They want to consume it off chain, on a on a DeFi application, anything like that. So these are the four steps. Next, we will look into the example tab, and we will first go through what it does, and then we are going to talk about how these four steps are being implemented in that particular tab. So let's just dive into the tab itself. So this is our example tab. This is a very simple tab. Say you want to send your friend, you want to send your friend some injective tokens, but you don't want to do it like, okay, I want to send one injective or two injective. You want to do it in a way, okay, I want to send $10 worth of injective to your friend. Okay. So this step allows us to do that. It has a contract implemented and the front end to do so. So let's just see an example here. I have I want to send $10 worth of an injective to a friend. This is my address, XU, and it ends with XU. Okay, this is my address, and this is my friend's address. So just loaded. So we have the latest data for this. Okay. So this friend has about $142 worth of injective in its account. I will just click on the send and maybe wait for 3 4 seconds. Hmm. I think some service is not working. Let's just wait for a minute, and when it will start working, I hope we can cut this part out. Okay. The service started working. Yeah. Okay. So this is the transaction hash for this particular transaction, and we are successfully able to send $10 worth of injective to this friend, which has this address and even TP. Before it had $152 worth of injective. Let's see, it should be around 152. These are dynamic prices, so it can be a bit different. Yeah, it is around $152. So we were able to send this was $10 worth of injective to this. And you can see there are other things also that is going on here. The current injective USD prices is also being shown, $10 worth of injective, which is here. So how all of this is working, we will look into the code for all of this and see how we have integrated with that. So yeah, let's go into the code. First, let's talk about the price. So we have the price service in our Pyth ecosystem that we have just seen. We can actually subscribe to that price service and can listen to the price updates. And this is what we are doing here. We are subscribing to the price feed updates. And you don't have to implement any of this on your own. There is this library, Pyth Network Price Service Client, which you can use to subscribe and get the latest price. And this is what I'm doing in this whole front end. So I have subscribed to the patch feed updates, and once received, all the calculation and front end can be done and it can be viewed on the front end. So, and once user clicks on send, we are using this helper method, send USD. Here we have implemented those 4 steps that I have just talked about. Let's just look into that. So, step 1, fetch the latest price. And this is how we fetch the latest price. VAAs returns you a signed price which can be sent on chain so that the contract will be able to verify the authenticity of that price update using POP code. This VAA is what contains the price update. Next, the step 2 was to calculate the update fee. For this, we have to query the Pyth contract address itself. And this is what we are doing here. The Pyth contract address get update fee for this particular VAs. After getting the update fee, the third step was to update the Pyth contract. In order to update the Pyth contract, we need to create an execute message. And you can see this is the format for that execute message. We need to update the price phase, the data is this. And also we need to pass the update fee. Remember the one that we calculated in step 2. This is that update fee. So this is one of that message. Now the fourth step was to consume it. How can do that? So this is a message that is being sent to the contract that has been implemented for this DApp itself, which is going to consume the latest price. How it is consuming this, we are going to look at the code for the contract itself. But yeah. So, and then this whole transaction will contain the Pyth execute message to update the Pyth contract address, sorry, to update the Pyth, to update the price on Pyth. And then we have the contract execute message in order to consume that latest price. Now, do remember that Pyth execute message should come first, then contract execute message. And the reason for that is first we need to update the price in order to consume it. So this is the whole integration on the front end. Now let's look into the context code itself, how we are consuming the Pyth price. So here, in order to consume the prices, we need to query the Pyth contract. And in order to do so, we need a Pyth contract address and the price feed ID. These are the 2 things which we need. And then we can use a method. So you don't need to use this method, but it comes with the implementing data structures that is being used in the Pyth contract also. This all has been exposed with this particular SDK, Pyth SDK CW. It has other data structure too, like the messages that Pyth accepts and everything. And you can use this. We are using on this method from this SDK, query price feed, because we just need to know the price of a particular feed. So let's look into the price, this particular section of this. Query price feed, we are actually querying the price feed using the Pyth contract address here and the price feed ID. It returns us a price feed response. Now, Pyth contract address can have a price that is not recent enough. And so we can actually apply a check for that. Now, there are other best practices too for using a price, and I have attached a link for that also in the resources. So you can go and take a look how to best use a price. So here we are getting the price only if it is not older than 60 seconds from the current time and 60 seconds, as you can see. Once we have received that price, now we need to use that price to do some math and calculation and everything. Here you can see the math calculations. Uh, and we will calculate the amount required in Injective to be sent to that friend's address, all this math and everything. And this is not part of Pyth and the calculation and everything. If someone wants to take a look at it, this code will be available to everyone and they can go and take a look at it. This contract is also expecting some funds to be sent to it. Reason being, it will use those funds to send to that friend's account. And once it knows that the funds it has been sent are enough, it will send the required amount in Injective to that friend's account. And if there is some extra funds that it has left with, it will refund that back. So this is how this whole contract is working. But the main point is how we are using query price feed to query price from the Pyth. So I hope all of this is clear. We are using these are the four steps that we need to do in order to integrate with it, get the latest price, get the update fee, update the price, and then consume it. And these are the links that I have been mentioning. This one is to calculate to get the price feed ID for different price feed. For example, if you want to check for Injective, this one is for Injective. You can look at different price feeds as there is one on the pitch website itself. How to use a price feeds and what are the best practices for that can be seen here. On-demand updates, if you want to know more about the advantages of it and everything, you can take a look at this. And here is the code for everything that I have just shown you. And you can check this repo out to read the code or anything. So, so we have talked about how to integrate with Pyth. We started with what is Pyth. We have talked about some of its features and those features like confidence, interval, low latency, high frequency data. And now it's time to wrap up. These are the resources that I have been talking about. If you want to check them out, go check them out. And that's it. Thank you.
Awesome. Thank you for the demonstration. Remember to check out the Peace Bounty program and finish the challenges. Thank you for joining.